you look at the transport info line to see if it had some information?
Yes, the information is correct. But then when I get on the train, I stay on the train and they keep, like waiting for another bus coming from Newcastle. And I asked the driver, hey, what happens? Because on the schedule, I see this early morning is work. And then he say, yeah, we're running, but we have to wait another bus. And I say, how long? He say, have no ideas. That's why
Oh my gosh. So was there a problem on the line?
I have no idea. They say at the moment they have only two lines. I mean, bus and trains that support that, and that's the thing. They completely rely on this, and they say, "Can I leave a feedback for the administration here? I mean, like the way you operate the train, because I completely rely on the train schedule." And is he? Yeah, but he say, sometimes it have to be like this, and I say, "Oh my god!" And that's why I call you.
Yeah, no, fair enough. Perfectly understandable. What's so what's the? Do you want to just show your screen what the error with drains
Okay,
is?
I show
Just so
you
I know.
now. May I turn off the camera so the speak
Yeah,
gonna be
of
better?
course.
There we go. Now, and I give you the control as well. Okay, easy. So screen, full screen. Yeah. Wow. Can you see it? Okay. And I give you the control.
Yes.
There we go.
Oh, I can't operate your drains model from here. I can only
Okay,
only operate the chat window.
Stop sharing again. So.
So if you just want to show me in your own way, that's fine.
Can you see it now? Now I'm gonna zoom it out for you.
Yep. just run the model.
I think I give you the control.
No, I can't run drones. I can only move things around on the chat window. I can't run drones from your computer. I'd actually have to get access to the computer itself.
There we go. So here the password. Never please.
So do you know how to run it?
Now. Yeah, I give you control. Yes, you can do
but
whatever
I can't.
you want.
Oh, actually, can I? There you go. Oh, there you go. All right, hold on. So have you done this before? Run with wheels or orifices in the light hydraulic model. Please run the full unsteady hydraulic model instead. Okay.
The dongle. That's why I can read the files. But when the first time I run it and I send you a screenshot which say there is you are running at the moment. Sure.
Yep. Yes. Yeah, so it's just running at the bottom of the screen. So all it said was you can't run the minor one because it's got wheels and stuff in it. You've got to run the complex model, which is fine. So no water upwelling from any pit. Yes. Freeboard was less than 300 mils. Do you know what freeboard means?
The freeboard. Wait, my.
Yeah, can you tell me what you think freeboard means, just so I know you understand?
The freeboard, that means the one that not touch the water level, is it? When
So no, it's from the top of the pit, Andy. So freeboard means that there's 300 mils space near the top of the grate. So when you are running a drainage model, what you're making sure of is that water is not being lost out through the top of the pit, that it's all contained within the drainage system. So you've got a few different elements here. So flows are safe in all the routes. Okay, so just hit OK. So I'm just cleaning my screen.
Yep.
So we've got, this is a catchment over here. So when you click on that, that's an area that's been programmed into it. So shows you in here.
Yep.
P3, so it's 420 square meters or 0.042 hectares. Default model, percentage of area, so it's 100% paved. Time of construction is 5 minutes, blah, blah, blah. So that's fine. So that's a typical roof area. So just hit OK. Then you got one over here. That's catchment as well. So 0.0215. Okay, I think it's saying it's generating 11 litres a second,
Yep.
which is fine. So 0.0215,
yep.
So that's fine. Go over to this one, 0.042. Yeah, so this is the catchment area, but you get 22 litres a second coming out of this catchment, and for half the catchment, getting 15 litres a second, which all makes sense. So there's fairly small areas.
Yep, yep.
This is the water in the pipes itself. So it's got your upstream and downstream levels. I'll just put this up. You'll see me looking up at my top screen, but don't mind me. It's just so I can read it better. So you've got your upstream invert level is higher, your downstream invert level is lower on a 1% grade using a 150 pipe. This is an internal design, so you don't need 375mm pipes in an internal design. 150 pipe is okay. So the other thing we can check too is make sure that the pits have a blockage factor on them. Are you familiar with what blockage factors are about?
No, please.
Andy? Do you know what a blockage factor is about? No, I'm asking. Do you know what a blockage factor is about? Okay, so a blockage factor is the percentage of the grade that the designer is assuming is blocked during a storm. So let's assume pits are not cleaned out regularly. They usually are not. They're usually never cleaned. So the pit will block to an extent. So this is like a buffer, if you will. So it's saying that, so between 0 and 1, 100% blocked, 0 blocked, what they're saying is 50% blocked, which is okay. Yep. So they've included a blockage factor in their pit design.
Yep.
Of course. Yes. Yes. So usually if it's a sag pit, it's 50%. If it's an on-grade lintel pit, it's 20% blockage. The reason is the sag pit is located at low points of your drainage scheme, and so all the leaves and all the muck and all the crap go down to your low point. So it's more likely in a low point that it's more blocked. If it's a curb lintel, it's only going to be blocked a bit. But in a sag pit, it's blocked a lot. So 50% is fine. So over here, 50%, that's fine. Go up here, 50%, that's fine. Go up here, blockage factor 0. Okay, so what they're saying here, junction pit or main hole sealed. So what they're saying is it's a sealed pit. That's why you can see here on this plan that the next pit in the line that activates, yeah. So let's just have a look here.
How you run it?
Or manhole sealed. So it's a sealed manhole. They're saying that it's got a head loss coefficient. So in the chat window,
is it a from or where we enter that from? I mean, no. In the command you are using at the moment, what command you just say?
It's from university studies. So did you study this at uni?
That's what. Wait, my browser.
Oh, okay. So I'm just putting something in the chat window. I'm just just in the chat window. Yeah. So what I'll do is, so this will also be in the drain notes.
Right. Energy
So
loss.
it's like Bernoulli's equation. Or is it KB squared on 2G? Yes. Sorry. Let me just fix that. So, yeah. So it's the head loss. So do you know what head is?
Please go for the explanation and listen.
Do you know what head is in hydraulics? Head. Yeah, do you know what head is?
Wait. Peter.
Do you know what head is? Yep, no problem. So if you just go, darn it, I deleted the wrong one. Sorry, let me just fix that. I'll just paste it in, right? So click on that equation in the chat window.
Is it something like the raise in the total hydraulic loss? It's just like a combination of pressure.
Yeah. Have you seen this before?
Is it?
Have you? Yeah.
Part of it. So yeah. So heads up is what I learned before. It's just like something related to the fluid and the water, and
so have you studied hydraulics at university? Did you do an engineering degree?
And turbulence caused by fitting,
part of it,
right?
Yep.
Yes.
Okay, I didn't quite catch the last part of that, but I think I got the gist of it. So what you've got in a drainage system on your pipe long sections is you've got what's called a hydraulic grade line. A hydraulic grade line indicates that when the system is running under pressure, gravitational pressure, do you know what potential energy? Do you know about potential energy?
Okay.
Hang on.
Remember the definition.
So I'm just writing in chat window.
This
potential
is like
energy.
something.
Do you know what that is?
Energy for the gravitation. Potential energy, is it related to
Do you know what that is?
mass?
Yes or no?
Of the object and acceleration due to the gravity and the height of the point. Is it? Yes, I'm listening. Please.
Due to gravity, correct? Yeah.
Yes.
So imagine a roller coaster for a moment. Thinking of a roller coaster? Hello? Yeah. So I'm asking. I want you to think of a roller coaster. Now imagine that you're going up to the top of the roller coaster and you stop. And you're getting ready to go down the roller coaster. Have you been on a roller coaster?
Yes, I did. Okay, did many times before.
Yeah. Hold on.
Yes.
Hold on.
Yes.
That's okay. All right. I'll send you a GIF of what it looks like.
Rob?
This is a roller coaster.
Yes.
Okay. So when it winches you up to the top, you stop, and that's potential energy. When you go down the hill, the potential energy is dropped, and the potential energy becomes kinetic energy.
Like
the energy of movement. So the velocity and the speed is based on how high you are and how far you fall. So gravity converts that mass into energy. So it goes from
I beg your pardon? Yes, I do. Please go.
Yes. Yep. Along so far? I said, are you following what I'm saying? Like, do you understand?
Yes.
Yeah, perfect.
Okay.
So this is the same for water in a pipeline. So water starts at a higher point in the system, and then it goes from potential energy to kinetic energy to flow through the pipe. So because the water is at a higher point and it wants to go down to a lower point, that's why it moves. And the way that we plot it, if you look at a long section, is you'll see a line being drawn on top of the pipe.
And you say from
that line is called the hydraulic line. So if you look at, I'll just bring it up on screen for a second. I'll say, share my screen whilst I bring it up. Oh, that's right. I'll just when I share it, it'll take yours off. It's okay. Just go to the pipes here for a sec. Skip the 500,000 curve return details.
Yes.
All right. This one's not too bad.
Yep.
See that blue line? Okay, so this is for a drainage pipe that's connecting into something that drops off quickly and looks like a basin, yeah? So there'll be a head wall here, putting water into the basin. They're assuming for this design storm or wherever it discharges to, I'll have to check it, is this is the top water level here at the basin for the design storm. So if this pipe is designed for a 5 or a 10-year average recurrence interval, so a storm that happens between like a 20% storm or a 10% storm. So there's, I'll just show you what I mean. So a 10-year ARI or average recurrence interval or interval is a 10% average, average following that on screen there. So this here, the 10% average exceedance probability here relates to every year you've got a 10% chance that you'll get a storm of that magnitude or greater. In the old days, they referred to it as an average. But what people thought is that if you got a 10-year storm this year, that you won't get another 10-year storm for another 10 years because it should follow the average. But what it means is you could get 3 years with 4 10-year storms and then get no 10-year storms for the next 40 years. But on average, it's every 10 years. So instead, what they said is they've changed the way they described it to a 10% average exceedance probability. So there's a 10% chance every year you'll get a storm that big or larger. So depending on what our DCP says for the design of this pipeline, they have to design a storm event for a particular size storm. And I'm just going to roll down here and see what they've included on their pit set out table. Okay, so that's drains, that's the 1% storm there. I don't know why they put that first. 1% storm, 1% whatever, 1% whatever, 10%. Okay. So this 10% AEP storm means that this is what the pipes are designed for. They're designed to handle this 10-year average storm. So it's a big storm, but it's not the biggest. Does that make sense? So the pipes are designed for a big storm, but not the biggest. So over here, what they've got, hang on, why is this not activating? I'm just going to go all funny. Come on. Right, so just going to poop its pants for a minute, so I'm going to have to wait for it. Right, okay, it's activated now, right.
Here we go.
Stuffed up again. It's probably just trying to process too much data at once. Yeah, but I think it's also, it could be the density of the image on the screen. It could be too dense. I'm just going to chop it while I wait. Come on. Right, I'm just going to scroll up and see if I can scroll out of here.
So for the rain, can I ask you something related to the rain model? Hello? So step by step, the first thing when you open the rain model, so what you gonna look at first? What and where you gonna? Yes,
I was nodding yes. Yes.
yes.
So, well, you just run their model to see if their model runs correctly. Then you've got to go in here and read these tables and make sense of what they've written. So what I'm going to do, I'm just going to close all this because it's just mucking up badly. I'll just close this window and I'll just reopen the plans because it's having a seniors moment. All right, I'm going to have to do a full shutdown on that. Task manager. There we go, we're back in task. Go away, whatever. Okay, open up those planes again. So it's stormwater longitudinal details, catchment plan, 400. So go down to 400, wherever it is. 100, a bit further.
Yes, we worked together before for this one.
All right.
I'm listening and thinking.
So have you seen a catchment plan before? Yeah. Do you know how a catchment plan is calculated? Do you know how a catchment plan is calculated, Andy? No, I'm asking if you know how a catchment plan is calculated. I'm asking you if you know.
No, please.
How they work out where those blue lines go. Do you know how they do it? The red lines. Do you know how they do it? I'll explain if you don't know, but I'm just asking if you know. I don't want to just explain everything to you if you know some things. Do you know how they set up these red lines? No? Okay. So each of these stormwater pits that they've got over here, they choose the location for where they think the stormwater pits need to go. So over here, for example, I'll just click on that again, clean it up. Just click over there and go away. That stormwater pit there has got some contours. The contours show where it points, the direction that it points is pointing in the downstream direction. So this level here and this level here is the same. But from here to here, the water level drops, I think. Oh, I think that's correct. Anyway, so...
Oh, yes.
Sorry, I'm making this issue confused. This stormwater pit here, all of this area around it, so there's a stormwater pit there, hidden under that box, so there's a stormwater pit there. So everything that lands on this property goes perpendicular to those contours. See what I mean? So all of these lines join at a right angle to work out where the raindrops go. So you go perpendicular down here to work out where the water lands. Now, if the water lands here,
yes,
and this is downstream, well, it can't get into this pit. Once it gets past this point, it's sailing down the road to this pit. So any water from this area in here is following this contour down to the road and going into the next pit. Does that make sense? So any water that lands on this block goes down here and goes into this pit. So this pit here is determined by following two things: a fence line and the contours. Now, the only exception to this rule is
Yes.
if this is a
Can we get
rural
the legend?
fence,
So the legend.
then there's a good chance that the catchment plan may not be correct. Have you seen a rural fence? Do you know what they look like? I'll show you. I'll go to Google Maps and I'll show you a picture of it. That all makes sense.
Yes.
Just go to Queen Street for a sec.
Yes, I did before.
So Cassidy, This is a good example. Now, is this appearing on your screen? The fence? Now you see that rural fence? Yep. So this rural fence here, for example, is the kind of fence type that they use for semi-rural areas. So what that means is that if water goes up to that boundary, it may not be stopped by that boundary. So this is on Queen Street. This is a rural area. So that wooden fence all around it is very similar in most areas. So over here, rural fence again. That means water is not really being stopped by the boundary. So your typical urban subdivision rules may not apply. So if we go to Ironbark Ridge, right, see that rural fence? So the question is, if this is a rural fence, what's stopping the water from this man's property going across to this man's property? What's stopping the water?
No.
So if it goes down the driveway here and the driveway is angled towards this man's block over here, what stops this water from going here instead of out to the road? Does this fence stop it? So the question would then be, the catchment plan, is it correct? Because in an urban design, so we'll just look at a different example, right? So fence lines are usually a really, really good indication of where water will stop. So that's fine. See that fence there? Go to the other side of the road. Fence there. Go down this road here. Fence there. Generally speaking, water does make it out to the street. But that's a good example, right? So when you have a fence like that, that stops the rain from going into your neighbour's yard because it follows the fence, either to the backyard or the front yard. But it doesn't go directly into your neighbour's property because this fence diverts it. So this fence here
Completely. Yes.
Oh, now I'm lost. Hang on. and this fence here are different. So this water goes to the front of the property. See that? This fence doesn't stop the water coming through. It slows it down a little bit, like around the stumps, and water pools around it and kind of goes maybe along the fence a little bit, but it's not like a hard barrier.
Yeah.
So water from this block will go straight under the fence. Yeah. Now, this says 18.1855 hectares. That means 1,855 square meters. So let's just call this 1,800 to make it simple. Yeah. So if it's 1,800 square meters, what is half of that? What's half of 18? 9. Yep. So each of these blocks is 900 square meters. So the next thing we check. Musselbrook, Shire Council, fencing. Let's have a look. I'll have to look at my folder here. So this is all related to drainage, which is why I'm going through it. So just bear with me.
The figure number 2 in front of the lot is that's why you divide it into 2, is it? You know what I mean? Okay. Yep. Okay.
Say again?
Yes.
Yes. Yeah.
Okay.
So this here is 2 blocks making up this area. There's a little bit of street in here, but that means that these blocks are probably about 800 square meters each. So this is referred to as a semi-rural subdivision, similar to Ironbark Ridge. So if we're looking at that, go righto. So we've got that information. Now we'll look at the subdivision DCP. Use the word fencing. Try the word rural. Next, rural or rural subdivisions. Yeah, so we'll keep going down. Provide some information. Hold on. Subdivisions and potential impacts, solar efficient implementation of environmental buffers. Ensure that rural subdivision reinforces the rural character of our area. So the character of the area would also probably include the fences. So the question is, that rural fencing, would that be something that they would put on themselves for a subdivision? No. Is it something that the person would put on later? Probably yes. So consistent approach to residential, rural, sub-residential, rural and commercial lots. Adopt criteria for that. Wide sizes, shapes and sizes, denote protected land use. And then
What
you've got
information are you
West
looking
End
for?
and DCP 27. Let's have a look here, DCP 27. I'll just show you one sec. So this is the DCP for the area. So we should review this in conjunction with our other subdivision DCP. So this section complements the provisions in our local environment plan and our development control plan, blah, 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 blah. So it says here's the area, right? So as far as we're concerned, this is our subject site. So new development maintains the village character of Denmark. Framework for water management, blah, blah, blah. Structure, staging plan, service strategy, open space, landscape, built form. Let's try that. Provide a built form consistent with that of a rural town or village. New dwellings with frontage to Armand Street should have the appearance of a detached dwelling in order to maintain the low density streetscape. Should be designed, sited, and constructed to minimise the impact of railway or highway noise or vibration. Development along the west and northwest boundary should give consideration to bushfire risk. Biodiversity, highway and rail noise, dirt. So we'll have to check the mine subsidence board to make sure that there's no mine subsidence in the area. I don't think there is, but I think it needs to just be checked. All right, and 2012, that was done. So I'll just see if there's anything else. All right, so we've got this overarching catchment plan. So these boundaries are without lots. So what it's saying is all of the water from this area gets into this creek system before it goes down to the next one. And all the water from this bit goes down here to this culvert through that area. This purple part goes through the middle of the site. And then you've got this brown area at the top there. So and then channel geometry, batter slopes of 1 in V, 6 high. So they're only meant to have 1 in 6 batters and 300 mil freeboard. So when it goes through our side, it's meant to have 1 in 6 batters. Currently, it has 1 in 3. So they're not in accordance with the DCP, if you know what I mean. So that's something we have to go back to them and go, well, this is not being designed in accordance with the DCP. Let's just go down the list from the top. Let's take it from the top.
Yep.
Probably easier to read from the top than the bottom. Right. So if you just type in Denman DCP 27, you'll probably find it.
Okay. So you are at the page 2. Okay.
Okay, I've now found. Oh, okay, there's another thing in the DC. Oh, sorry, the OSPEC here. So it's all right. Minor and major system set out. Blah blah blah. Major system, which is down the channels. Minor system carrying flows for more frequent runoff events. I'll look if there's any other details.
Yep. Ê, bố kìa.
Oh, here it says, so if any flood water goes into a property,
Có bố không?
then the IAD system has to be increased to 100-year design with blockage factors. So when it surcharges. So if they can't contain floodwater in their development, in the roads, if the water doesn't fit in the roads and spills into property, then the IAD or the inter-allotment drainage at the back of the properties needs to be upgraded to a 100-year design. Does that make sense? So the 100-year flow can't end up being ponded in someone's backyard. It either needs to go down the road or it needs to be upgraded. Catchment area. Catchment area land use shall be based on the available zoning information. Rational method. Coefficients of runoff shall be calculated as volume 1 of AR&R, full details of coefficients. So this is the coefficients are based on the impervious and pervious fractions. Do you know what impervious are? Yep. And coefficients of runoff for specific locations. So we would need to look at AR&R and work out if it meets the requirements. So that's fine. We'll just move forward on that. Time of concentration to get to the front of the site, blah, blah, blah. Where the flow path is through areas having different flow characteristics or includes property and roadway, then the flow time of each portion of the flow path will be calculated separately. Maximum time of concentration will be 20 minutes in an urban area, unless there's evidence to provide a greater time. Flow paths to pit shall be representative of the fully developed catchment, considering things as fencing and the likely location of buildings, and have shown for each collection pit on the catchment area plan. So that's really important. So I'm going to just screenshot that. That's the important note that we're taking away from this. This is really important because you don't want the neighbour's water to flood the property downstream and cause a nuisance or a problem. So in our chat window, I'm just going to paste that in. So that's from yes. No. This is OSPEC, mate. Yeah. Yeah, this is OSPEC now. Yeah. The rural residential land has a runoff coefficient as dedicated below. So, so the flow is AR to the 2/3 times S to the power of a half all over N equals Manning's equation. Yep. Now, A is the hydraulic area, R is the wetted radius, S is the slope, N is the roughness factor. So that's where these numbers come in for N. So you see the N there? That relates to Manning's. So that's the Manning's equation. So you can look that up anyway. Manning's equation is a channel equation. It's a very common equation you would use to work out that everything works. Alternative models of the hydraulic models can be used as long as it's satisfied. Blah, blah, blah. Give us the final data files. Da-di-da-di-da. So there's information in here. Hydraulic grade line. Downstream control. Okay. So the known grade line level from downstream calculations, including pit losses at the starting point, where the downstream starting point is a pit and hydraulic grade is unknown, a level of 150 millimetres below the invert of the pit inlet is to be adopted. So below the bottom of the pipe, 150 below the bottom of the pipe. Where an outlet is, and the design storm is a minor event, top of that outlet, sorry, the top of the outlet of the pipe shall be the downstream control. Where the outlet is in an open channel, design storm is the major event, and downstream flood levels are not known, the top of the outlet pipe shall be the control. So it's basically saying that the pipe is full up to the top of the pipe. So if the outlet is an open channel the design storm is a major event and downstream flood levels are known, the downstream flood control shall be the 1% probability flood level.
Yes.
Water surface and drainage pits shall be limited to 150 millimetres below the gutter invert for inlet pits and 150 millimetres below the underside of the lid for junction pits. So
yes.
Water should not come out of it. Does that make sense?
Yep.
Okay. So when we're talking about flow paths, we need to understand the fencing. Doesn't it? But here's the other part. These are also smaller blocks. Yeah? They're not tiny, they're bigger, right? So here you would expect a big house to be in the middle.
Yes.
So any water from that house is going to be taken to the street through a square box section. So a small curved inlet pipe, either a circular or a square pipe from the roof to the gutter. Yep. So that means that only some of the water around the house can get through the fence. Does that make sense? But that means that, many of these backyards, so the water droplet could come down here following the curve, hit the house, go along the house, and then follow the house down to here or to the fence line. So these catchment areas are okay for these smaller blocks because the house and the fence will generally take the water from here down to the street because there's a house on it. Does that make sense? Okay. Now let's look at the bigger blocks. Bigger blocks are a little bit more of a risk because the house could be in the middle but perpendicular. So the water here is going to go straight down to the road here. So that's correct. But because we know there's a pit under there somewhere, water from here, it's saying is going to hit that fence and travel along the edge of the fence before it goes through to the pit. Maybe that's correct. These aren't perfect. Catchment designs are not perfect because you can't model every raindrop. It is meant to be like a good representation of what's happening, not a perfect representation. Does that make sense? So this kind of a plan is not meant to be perfect. It's meant to be a good guide, like not too bad. Like it's got to show logically that the water should be flowing in the right direction. So this is a pretty easy exercise for most engineers. You go from the pit, you go at a perpendicular angle to the contour, and you follow along or you follow the fence line. So in this case, this fence line generally controls the water because there'll be a house in the middle. Fence will control some of it, blah, blah, blah. These two blocks here have a flat grade that generally takes their water down to here. This one here is saying that because this grade is flat, and I think this water is going downhill here, I think it's saying that, if the water lands there, it's going to travel along the fence to get through there. Maybe, maybe not, I'm not sure, but he's included that block. That's not too bad. Now, these blocks here are the tricky ones. These long blocks. Now, why are these long blocks different?
Yes.
To me.
Go ahead. I'm thinking about the reason why the long block is going to be more.
So think about the example I just gave of the house. Picture a house on that block.
Yeah.
Can you picture a house on that block in your head?
Yeah.
Yep. Yeah. So.
Yeah.
Just more space. If they want to put a horse on it or a cow or whatever, I don't care. But here, right? Here is the size of a block that supports a house. Here are the blocks down here. right? Generally, you may not want your house right up here, like in this area. Maybe you want it set back somewhere along here, offset a certain distance. Our DCP will say what the minimum is, but there's no trouble. You can have your house further back. You just can't have it right on the road. Does that make sense? So here, if we've got houses, stopping about, let's say most of the houses are going to be in this first half of the block. Yeah. So that means behind the house, all that water is controlled and it's taken down to a pit in the backyard. So the roof water should have a connection that takes it down to the pit in the backyard. That's generally fine. But the question is, if this raindrop here goes through the fence, because the house is up here, goes through the fence, through the fence, through the fence. You could have this whole corner section of the backyard here going through a rural fence. So you could have water that's just flowing through people's backyards and is not controlled.
Can we build
so what do you do?
Or,
so if you can't control what's going along there, what do you do? If you can't control the water and it's going to go into your neighbour's property, what sorts of things can you do, Andy? I want you to tell me.
Yeah.
Have a guess.
Yeah.
So we've already got a pit. See that little blue line? There's already a pit there. Yeah, what I'm talking about is the water that's getting through the fence and going through many, many backyards. So if you get a big storm here and the house is up here, right? Let's pretend the house is up here. Then water from the backyard could go through this rural fence, through that rural fence, through that rural fence, and end up in this corner over here, somewhere in this guy's backyard before it hits the embankment. So we need to check the sections here of what can flow over the acoustic mound. We might need to have a table, like a concrete table drain through the backyard. Yep. No. IAD, inter-allotment drainage. So interlot drainage. So here we've got a pipe and a pit. Problem is, water could go over the acoustic mound, maybe. Maybe the water is not controlled. So the question is, do you have a concrete spoon drain along the side of each one of these properties to get the water down here? Maybe. That's a question for the consultant. Do we need one along here? Maybe, if there's a risk that this stormwater is not controlled. Because at the moment, it's saying that all this water is stopped by here. So let's go back because we've got some section views further out. Where's my section views? It's all the road stuff.
Oh, you go back to
I don't just have cough off camera. Right, I'm just trying to find where it's got section views running through the space and so I can see everything. Huh? this is all on the street, gentlemen. So I'm just looking for a section view that shows me what's happening through these different areas. I remember what set of plans I saw it on. So that's the road long sections, typical cross sections. Section A, right, so the same, that's the swale at the back there, right? So section A, got to find where it shows section A. Let's go up. Section lines are. I did see sections on other plans. Just don't know why they're not in this set. That's very confusing. Right, let's try.
Yes.
Oh, it's the same one. Oh, DA plans. Oh. And I had the sewer plans that a minute ago. I'm just trying to find them.
What page is it?
Oh, okay. So this is the other set of plans. Okay, so this might have the section. Ah, here we go.
Yep.
Right. Yep. So see the section here. So anyway, it's one of the set of construction plans for bulk earthworks and all that. It's in the file folder in Content Manager. Yeah. Yep. So anyway, because I'll just need to get through this quickly because we've been on the phone for an hour and I just want to get you to a point where you can be more confident. So this is section C running through this block, right? So we've got the acoustic mound here. It's a typical section through a property. It'll kind of show us what's sort of going on. So we'll look for section C down through the plans here. A, B, whoop, D, no, B, D, C, right. So here is the road. So it's going from lot 362 up to the road. So we'll just go back and see where that kind of links in. Yeah, so here at 362, it's saying the data is going up to the road. So if that's the case, we need to make sure that that lot can actually drain. So lots section C, which is down here, is showing that the water is trapped. See that? But if we go to the catchment plan, because the catchment plan and the earthworks plan should kind of be together, make life a lot easier. So where's catchment plan? Oh, hold on. Oh, that's development application plans. I'm looking at the wrong ones. Hold on. This might be everything. Maybe this is the wrong set of plans before. Intersection curve return details. Oh, okay. Stormwater calculations. All right. I think I was looking at DA plans by mistake. Don't mind me. Okay, so page 600 is your stormwater plan. So let's scroll down here to see the stormwater plan, stormwater catchment plan. Here we go. Look. Okay. So, yeah. So if we just stop on this page for a sec, let it load up. It's just there's a lot of rendering on here, so it's using a lot of resources to try and load up the page.
Yeah.
Now, what's weird is, see this here? It's suggesting it all drains to the road. But this batter is going up to natural ground. So the water appears to be trapped. So if we go to, where is it? Hang on, I'm getting confused with all these different drawings in different places. Hold on, let me just move this over there. Too much going on. That's that plan. Close those other ones because they don't help. All right, so here it's showing catchment plan draining to the road. So somewhere along here, there'll be a section plan for earthworks to start, which shows that the water is being trapped by a batter, which he hasn't picked up on. So here, they're filling this area. We zoom in really close on the batter, see how this batter line is nearly touching the edge, and then that's a half point. That means this is the bottom of the batter. So water is being trapped along there. So what he should have is there should actually be a pit in the corner there because 118, 119, 117. So water's draining down to this corner. Where's the stormwater pit for the corner of this yard? There is none. So if that's the top of the batter, then these should all have stormwater pits on the other side here. So lot 363, lot 362, lot 364 are not draining properly because of this fill area here. So I'm going to make a note of that. So he's just missed it. So that stormwater pit there should have a connection either at the bottom of the batter and go across, or one there, one there to come across. So what I'm going to do is I'm just going to go Control All, go to my notes here.
Are you working on the work file you upload into? Oh, okay.
All of this is Almond Street. This is all Denman. All of it. Yeah, so this is the one you've already got a link to. So now what I'm going to do, okay, so here's the other thing, right? It's suggesting that's a fill batter going up. Oh, sorry, a fill batter going down to the property. If that's a fill batter going down, then that corner also doesn't drain through like that. So I need to make another note here.
Yes. Then the water, no color.
So overland flow path does not flow in this direction. The road is higher than the lots. Does that make sense? So the green area is fill. So if the road is higher than here, how does the water go that way? It doesn't. it would come out over here somewhere. That's if that's in cut. So the water would flow all the way over here down to this path here. So, and he's got these bags in the middle of the road here or whatever. That's not correct. It would actually be over here. So these would disappear during construction of the roads, which would happen not long after the earthworks. So you've got your earthworks and then you've got your roads going in. So it's partially correct. He hasn't really staged it to show the two parts of the plans. All right, so let's just go to section view for the earthworks to show him. All right, so we're going to take that. Say, sir, you are a dingus. Wrong. You got a trap low point there. You need to resolve it. And we're going to go down to the section C, and we're going to highlight it and put a big red circle around it. And then we're going to bloody draw all over it in red pen. Red pen.
Yeah.
Actually, hang on. All right, I'm going to write it out. Actually, can I go? Let's go edit, undo. Yeah, I'll just do it again. I'll just do the text underneath it. Drawing in text is painful. Okay, so we'll just do a circle. New, oh, darn it. New step, do it again. So
yeah, the first one. Yeah.
So this spells it out to the consultant, say, hey, you got a track low point here. So that's the first part, right? So the catchment area there should have a pit in the backyard. Pits for trapped low point to be included in the design. Save. So now I don't need to worry about this later. So it's got the lot number on there, shows the section, shows the fill area, shows the overflow path, and I've got my notes on it. So you just paste this. You can just paste notes and send them through. Like, it doesn't have to be fully formalised. Now it's draining down to the black of the block. So you've got road 2.
Oh, okay.
Yeah. Then it's going down through that long block. Yep. So we'll go back to the notes.
Yeah.
And I'll show you what that looks like. So from change 45 to change 150. Yep.
And then down.
So 45
there
to 150 is the end of the batter. Right. So 45, here's the front of the lot.
So
there's the boundary. Goes all the way down to the back of the lot. And then this mound, the mound goes up. So what we know is the water is trapped there, which is change 135. So we go back to change 135, and that line there lined up with the basin. So that line next to the basin is your low point. That's where the batter's go. And you see the contours, how they finish at that line, and then they curl off again. That means that is your low point.
Okay.
Where it's when it points like this, it points upstream. This area is downstream because this point here gets higher and higher and higher and higher to here. And everything in this area is lower, 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 lower. So this points upstream whenever you see a triangle. So if you see a triangle, that's upstream, and the fat area is downstream. Does it make sense? Yep. Okay. So now we'll go back to the design because we're going to look at that drainage design again. So we found something in there while we're doing our work, which is good. Go down to the catchment area. Okay. Okay, so catchment plan. So it's saying anything to the top of the batter flows back to that pit. Correct. So that's the crest of the batter. So this area here is battered down. So water lands here, goes into this backyard on that line that lines up with the edge of the basin. Correct.
So we don't need the front range.
But
Yep.
what we also need to consider is, do we need a spoon drain or a concrete drain along there? Maybe not. It's all going to flow down through people's backyards along the grass anyway. But, well, maybe not. But here's the thing. What's stopping people from digging into this batter and making it a garden that gets more sunlight? Do you know what I mean? So this batter that they've got here, let's just go back to the plans.
Yeah. Brilliant.
Yeah, so where it goes to the end of this and then it kicks up, that raised area over here could be used as like a terraced garden. They could be turn that batter into a garden. So maybe we want a concrete strip drain or a V drain put down through this property to carry the water down there. Because a concrete V drain kind of means don't go any further. Don't dig up this area. There's something hard here. We don't want you to dig up because it's not likely they'll remove concrete. Then, yes, to take it down here. So we might say we want a concrete V drain along there. The reason is we want to create a physical barrier between the acoustic barrier. We don't want them to dig into it. We don't want them to pull dirt out of it. That concrete drain will kind of say, don't drive vehicles over it. This is all part of the infrastructure here. You know what I mean? Because they'll have this big pile of dirt in their backyard and they'll go, oh, maybe I'll borrow a bit of that dirt to go build a garden. They can do it. They can do it. Absolutely. And who's going to stop them? But if you've got a concrete strip drain, it's also a visual barrier. It's like, don't drive your equipment over here. Don't drive your truck over here. There's a concrete drain in front of you at the bottom of this barrel. It's there for a reason. And then you cover it with a B88 instrument.
Okay. Yeah.
So the next question is, are we going to have any nuisance water?
Okay.
So this batter goes down into the property. So up here. See where that batter line reaches down? It almost touches here. And then this is what, so this means the batter starts up here. That means it finishes down here, which means that's downhill. So all of this water has to be kept in the road because anywhere this batter goes down into the properties, if it goes over the driveway, then it's going to be a problem. So any water that goes down a driveway is going to pour into the property during a 100-year event, which means that this pipe and this pit needs to be upgraded for a 100-year event. So we want all of this to be contained in the roads. We also want to design that if we've got a batter like this, we should be checking the drains model here and making sure that the height of the stormwater, so the height of the stormwater in the curb, is not greater than 150 millimetres. Do you know why? Why do we not want the water to be higher than 150 millimetres during a flood? What else is 150 millimetres in a road, Andy? The height of the curb. The curb and gutter is 150 millimetres high. That's what keeps the water in the road.
Yeah. Because...
No, not following? Okay, hang on. Let me bring up the detail here.
Because my flow of thinking is lower, and then your question is just come in, and then
so I know this is a lot of information. I do apologise. I'll just No, it's okay. It's just I'm giving you a bit of a crash course because there's a lot of information that you need to do your job effectively. So I'm just trying to give you as much as I can.
Go above. Yes.
Okay, see this? See how that's 150? That's the top of the curb. So when the road is flooded, you don't want the water to go above here.
Into channel, yes.
If the water in the drains model, so when you've got overflow,
that's the
and
whole
you've got some
you
sections
discussed
showing the
before with
road
me.
in
Yes.
certain areas,
I got you.
you don't want this flow, the overflow. So you've got flow in your pipes, and you've got flow in your channel. So the flow, the channel is your road. Your road becomes a channel. So correct. So if the water is greater than 150 millimeters, it means the water goes over the curb and down the hill to the property. So now you've got uncontrolled floodwater going towards houses. So when you check the drains model for this site, I don't know if it's on file or not. We have to ask for it if it's not there. But when we check the drains model, we want to make sure that the sections through there do not exceed 150 millimeters. So a little bit of water, we know that all footpaths go up by like 2% before they fall down. So when we look at a road profile or our agreed road profile, even a road that goes downhill, has a 2% grade going up. Then it can have a 10% grade going down. So there's always a little bit of grade going back to the curb and gutter. So that section along there, that triangle, is where the water is contained in the road. There's a little triangle over here from the top of this 2% here. There's tiny, tiny, tiny little triangle here, which is a little bit of protection before the flood water goes down the hill into someone's house. So the risk that we have, if there's too much flood water in the road, then water goes down into the property. If it goes down into the property, you need to upgrade your drainage pits in the backyard to a 100-year design so that all of the overflow can fit in the pit. So instead of 150 pipe, you've got a 375 or a 450 millimeter pipe in someone's backyard. It becomes much more expensive. And the deeper your pits are, they can go from like 2,000, 2.5 grand to 3.5, 3.5 grand, plus for a stormwater pit. So a stormwater pit somewhere between about $2,000 and $4,000 per pit installed with a grate on top. So very expensive. So in engineering, they try to build as much as they can for the lowest price by thinking about the design so that you don't dig too deep and you don't dig up too much road and you don't have to bring in too much fill. So when you check the drains model later, this is not for now, but for later, you'll be checking cross sections along this road here to make sure that that water doesn't go above the curb line, because if it does, it spills down into this property. Does that make sense? Just all logical stuff, just all very logical. Whoops. Hang on. Oh, that one dropped in the bin. Okay.
Hi, Peter.
Try to show you
I have a question. If I can I
all right.
come back to the brand model later by myself and I run it and I do everything.
You to have
if
a little
I
bit
have any
more look at
question,
the plans,
because
get more
while
familiar
you
with
are
them,
teaching me, I know
and then maybe
now
set up a
some
meeting.
then I come back
Either
to
next
that
week or
later.
tomorrow, because
And
I'm
then
on
if I
leave
have
from
any question,
Thursday.
can I send an email and ask you? Because sorry, but there should be some stupid question because something it's gonna be related to the terminology or something that's still new to me. So if I cannot search from Google or any, can I just ask you?
Yes, of course you can. So the other thing, go out.
Okay.
All right. Yep. Of course you can. Now, the key thing is when they've got Hume guard shown at the moment, we might have already told them Hume scepter. So a Hume guard or a Hume scepter will have a K factor for the pit. So
And yep. Peter, can before you go, can I ask you something?
Um,
So at the moment, I'm still working in Almond. I finished my review for your on of your assessment. Yep, but the thing is, I am going ahead with like engineering plan and
yes, of course.
like the earthwork. And what I'm working at the moment is I go to like like I go to any
Hmm.
document related to assessment of the DA. For example, like the guidelines from Cessnock, the guidelines from Blacktown, and the guidelines from Maitland about how they assess the DA. Then you have any advice, a piece of advice for me, or you think it's like
Yep,
waiting time to read all of these guidelines and I just come back and then oh,
yep,
oh
yep. Probably. It's probably a bit of a waste of time because we're not actually
yep,
getting anything done. So you remember the advice I gave
okay,
to you the other day. I said what we need to do
yep,
is we need to review
yep,
one thing and then go through the plans to check
oh,
that thing. So I've already created more advice here. So reading and reading and reading and reading and reading won't
okay,
teach you anything. You need to read and apply. Read and apply because you need to
okay,
reinforce the things you're doing, right? So I look through the plans, right? Now the shape of this land is going up towards the block. This contour
yep,
shows water's flowing down here and then it gets trapped. So I wrote here, just took a picture, trap low points to be resolved. Refer to section C for earthworks. Overland flow path does not flow in this direction. The road is higher than the lots. That's the kind of advice I want coming out of you. So I want you to go through
yep,
and include things like acoustic wall shown in section CC. So you might take a cut of the other end of the section, just say may be used by residents for landscaping material. Recommend concrete V drain
yep.
to create visual barrier to protect acoustic wall, for example. Now, we could have asked for that at DA stage. It's only occurred to me now. But
Peter,
in the meantime, we need to get that
sorry, I
Victoria
just jump
Street one
in
done as
between.
quickly as possible. That's more
So
important
for
than Armand
Victoria
Street
Street,
because we have
for
the
just
drains model.
say
It should be
what
quick to
task
finish.
would you like me to
Anything that
do
we can get finished
in that
quickly, I
one?
want you to do your
What
best on it.
criteria
And
you
if
want
you
me
are
to
like, if
assess,
you are still
please?
struggling a bit, Andy, it's no problem.
The
I'm
note.
happy to. Sure, sure.
Yep, yep.
Okay, so yeah, yeah. So you see that note I just wrote you? Yeah, head loss factor in a pit might be 0.5, etc. Hume sector will be 1.3 with a right angle unit. So I'll write the reason why. So Hume guard specified wrong. Hume's, hang on, I'll just write this in the notes. Hume sector
Window are
was
you
the
typing?
unit
Is it in? I don't see.
to
Oh, here I see you
use.
typing now. Okay.
The pit icon saying Hume guard will have a K factor for
Yeah.
yeah, yeah. Hang on. I'm trying to write it all out. Because what I'll
Peter.
probably need to do with the Andy is I'll probably need to go through these projects with you
Actually, I really need
line by
look
line,
like to
section
see
by
a
section,
map.
and explain
You know
everything
what I
as we
mean?
go. Because
Map
I
just to
probably need to
include
show
like
you
some
everything. It's
bullet
probably
point, just
you're probably
in
getting
short,
stuck,
and then I just
not
go
really sure how to do these jobs, and I probably
bullet
need to sit
point to
down with you a
bullet
lot more
point
and
and
actually
see.
take you through them.
I will
Because I
accept
can do
every
work on my own, but I
single
probably need to
bullet point
work
that
with
you
you to
put
show
in
you.
the map.
Yeah.
Just follow your, the progress. Yeah. Uh, Oh, yeah, yeah,
Yeah.
like a checklist.
So
Yes, correct. A
yeah.
checklist.
So the reason I haven't done that yet is I haven't got time to write all of those bullet points because there is so many parts to this that I can't create a
So that I
template
can,
or a easy
follow
checking
you and
guide
then
for
go
what's in it. I'm
parallel
sure that
with you,
there
because
are.
if I go by my
Yeah,
direction, you go another
I haven't got
direction,
a checklist
then we don't
prepared.
have a
So
common
let
voice.
me just look at my previous emails and see if I can find a checklist from one of the other councils. Hold on. Development checklist. Yeah, but I didn't really know up till now that you were struggling with lots of things, that you haven't really got a lot of experience. So I'm trying to think about what I can do to kind of help you to understand better how to review things, because I thought you'd have
Because
a little
because the
bit more
checklist
of
you
an
give me
idea of
from
how some parts
like
came together,
Macquarie,
and there's probably
and then
lots of
when I
things that you probably just
go
need more
through
help with,
all
and
of
that's not a
them,
bad thing.
they don't
But
mention
it
anything
just means you
related
just need
to
more help.
engineering plans.
Um,
So that's why I'm
Hang
trying
on,
to look
Rodney
up online
Stanners.
and
Hi
see any
everybody, I'm looking
reference
for a
or guideline I
checklist for
can
reviewing
follow. That's why.
plans.
Yeah, that's correct.
Yep,
For the engineering plans, to be
yep.
honest. Yes. So if I get any like a guideline
Yeah,
or
but
whatever, and
right.
then I can
But
start from
do
that, and
you
then I
not
can
know where to
follow up with
start?
that, and then I can create my progress
You don't know
and
where to
whatever.
start.
But then now I get lost completely, to be honest.
You don't know where to start. Ah, okay, righto. Huh. Yeah. Okay.
The
Okay.
thing
So
is, after I
what
do my
that means
review and
is
then I
that if
send to you, and then
you're
you
not
come
feeling
back with your
confident, you need to
assessment,
let
and I
me know
say my
sooner rather than later,
review
because
is
I assume
useless.
that you're
Like
off
they
reviewing
play.
things, and if you don't know how to review things and you're just being quiet about it, it just means that we won't get anything done. So give me a second. Um,
Okay.
yeah. I understand that, but I don't know what you know and what you don't know, because I haven't really seen your good work yet. I just see that you're trying to learn lots of
So
things, and
if you
that's
have
okay too.
any
There's no problem with that. I
something
don't
like,
mind. I've just got to work out
yeah.
what your ability is or what your capacity is. And at the moment, I'm still learning about your capacity. Um, okay, that's interesting on roundabouts. Oh, okay. Now, I'm just looking up for it now. Hold on a sec. Sit tight. Hang on. I'm just gonna save. Just finding things that go through, creating all this stuff. Nope. Drawings and manuals. Yeah. Okay. Development. Um, Yeah, so one of the things that I wanted to do, and what I've been stuck on. So before I had a design development engineer with me, I didn't have any time to write these documents that would help teach you what to look for and how to check things.
Yeah.
So coming on board, I assume that you might know some things, but you're obviously just struggling with
But
lots of stuff. So what I probably need to do is sit down and write out a list of everything that I can think of, but writing out that list means that I'm not working on other stuff. So it'll take me a few hours to build. So leave it with
yes,
me. I'll think about what I can put in to help
yes,
you to see
yes,
things through my eyes and help with a checklist. And that checklist will be related to the Denman job. So in the meantime, I want you to
yep,
finish the Victoria Street job. I want you to click on the pit that says Hume Guard. I want you to check what the head loss
yep,
factor for the pit is. And I want you to make it like 1.8 or something. So Hume Scepter head loss is 1.3. is the
Okay.
factor,
Okay.
but because
Yep.
it's a
Yep.
right-hand
All right.
bend
I
through the
follow your
unit,
guidelines.
it's probably
Yes.
going to be about 1.5, 1.8, something like that, and then rerun the model. And if it reruns the model based on that, everything is okay, and we tell them to
Yep.
put it in STC2
To be
instead.
honest,
The
it looks
end.
like I am
So that's a
burden
quick
you. You know
one.
what I mean? Because
Cool beans. All right, you run with that job for now because it's going to take me some time to write checklists for
yes,
everything
please.
for you. So just give me a few hours because I'll need to punch through it as quickly as I can. Excellent. It's Andy, it's okay. If you are honest with me and say that you're not sure what to do or how to do it,
Yep.
I will
Because
find ways to help you. That is my goal as a manager. So don't worry. If you're confused,
for
just
the
tell me you're
aspect,
confused. Just tell
like
me
on
you
the
don't
work
understand.
aspect,
Tell
I
me that
can
you
do
don't
it
know. Just
by
be totally
myself. But
open and honest
like
and say, I don't know
I feel
what to
like
do. It's not embarrassing because it means that I will spend more time helping you. Because the time I spend helping you means that you can do that work on your own in the future.
yes. But okay, so I follow what you told me
But
to do. You telling me to do.
if you've
For
read through all of OSPEC
yes.
and you don't know where to begin, it means that you don't know how to apply the OSPEC standards
Yep.
to the design. So I'll have to find ways of connecting that
Yep.
information for you to help you.
Okay.
Yep. Just do that first. I'll need a few hours to
Yes.
write up some
Okay. Thank
documents
you,
for
Peter.
you and try and put in
Yep.
as many things as
Enjoy
I
your
would
lunch
check as
and
possible.
take care.
And then I'll
Yep.
send it through to you to help you
Yep.
guide you while I'm away on my leave because I do need to give you that guide, otherwise you'll get stuck. So I'm happy to do that because